Hello, grade 8s. This morning we're getting into our next chapter, chapter 9. It's on linear relations. We're going to go through a wee bit of vocab, and then we'll get into the heart of the lesson, and then you guys will get some problems to work on. So one of the key things is we are talking about relationships. So we are going to have two sets of numbers that are going to relate to each other in some way. And you are going to see even a pattern emerging based on these relationships. So there's two sets of numbers. One example that I thought of, it's kind of a disappointing example because when I got Tim Hortons hockey cards this year, I got, one of the cards was Ryan Getzlaf, and I was really upset that his hockey card was in that pack because I'm not a big fan of the Anaheim Ducks, but I know one of you are, so, or is, so you might be happy about that. But anyways, in these packs of Tim Hortons cards that, I don't know if they were $1, I can't remember exactly how much they were, but I think, let's say they were $1 and there were 3 cards in a pack. So there is going to be some type of relationship based on this, and a pattern can form. So, and it allows me to make further predictions as well. So if I follow the pattern for a little bit, 3 cards I can buy for $1. I could get 6 cards for $2, 9 cards for $3, and eventually I could predict, oh, if I had $10, I could get 30 cards. Or if I really wanted to get 36 cards, I could divide by 3 and be like, oh, I need $12. I need to go to Tim Hortons with $12 in order to get these hockey cards. So yeah, one way of describing these relationships is just using words like this. Another thing that we're going to run into is something called a table of values. And so this one's fancy with different shades of blue or purple or whatever you want to call it. But you can simply draw one of these by just making like a T-chart in your notebook as well when you do some of these problems. This is probably the easy way of doing it. I could put cost here and number of hockey cards here. And so it doesn't have to be as fancy as this, done on a computer. It could just be paper and pencil, draw a T, and describe your relationship. So this is just another way of doing it. Maybe a bit more of an organized way where if I have $1, that's going to get me 3 hockey cards. $2 is going to get me 6. And it's just another way of showing this pattern, this linear pattern. I guess we have not talked yet about why this is a linear pattern. There's another way that we can show this information, and that is by way of a graph. And so if I looked at this graph, if I can also put numbers on here. There's 1, 2, 3, 4, 5, 6. Maybe I'll go by 2s. 2, 4, 6, 8, 10, 12, 14. And so if I have $1, that's getting me 3 hockey cards. 2 is getting me 6. 3 is getting me 9. 4 would get me 12. And we can say a relationship is linear or not if I have a ruler or a meter stick or something straight. If all of these points go through a straight line, it's a linear relationship. That's one of the key points. Say it one more time. If all of these points lie on a straight line, it is a linear relationship. So let's see if that happens. Can I draw? It looks like I can draw a straight line through all of these points. So this is a linear relationship. And well, we can see the word line in linear. I guess we can always also see near and ear, and that's about all I can see so far. But yeah, but the key word here is line. So these relationships, they form a line. That's one of our key ideas here. Okay, so yeah, we have already talked about table of values, but in grade 7, we've mostly just have dealt with this quadrant of our table of values, but we just did a whole chapter on integers, so we know some negative numbers exist as well. And so here's my quadrant where all my values are going to be positive, but it is also possible to plot negative integers or negative values. I guess they don't have to be integers as well. Another thing I'll say about a table of values is this column on the left always refers to my x-axis. Even if an x isn't written there, any number in the left column is always going to be plotted on my x-axis right there. It's the horizontal. The second column always represents my vertical axis, my up and down, in this case, my y-axis. And that is just one of the conventions of math. That is always the case, horizontal, vertical. There is another way of showing a table of values that you might run into as well. So instead of columns, it can also be in rows as well. So I could have x here, y, and then -6, -3, 3, 6, -10, -8, -4, -2. So this is another way of doing a table of values as well. In this case, the first row always describes the x-axis, even if an x isn't written there, because this is going to happen, and there's going to be other patterns that we're describing. So there's going to be other variables in this first row, and same with the second. But the first row always relates, or always corresponds, always matches up with this x-axis. The second row always matches up with the y. I could even, I don't really want to do this, but even if I swap these variables, even if there's a y here, I still can't plot that on the up and down. This first row always relates to the x-axis, no matter what that variable says. Okay, so these can also be plotted. So in order to do something like this, if I was going to plot this point, x -10 and x -6, y -10, I'm going to start at 0 on the x-axis. I'm going to move over to -1, -2, -3, -4, -5, -6. And then I would go -10 on my y. That's going to be all the way down here. So right there would be that point. You guys might also see these as coordinates or pairs, and so whenever you see, like if I was asked to plot this, the first number always relates to the x. The second value always relates to what I'm going to plot on the y-axis. I could plot this point as well, -3, -8, -3, -8, 3, 4, 3, -4, and 6. And could these be a linear relation? Well, we'd have to hold up maybe a ruler or something that's straight, and will all those points go through a straight line? Yes, they do. We could say this is a linear relation. Okay. You will be asked to describe these patterns in 3 different ways. Let's talk about them. Number 1, what this graph relates to, where it starts, and how it changes. So when I get to a question like this that says describe patterns you see on the graph, I want to talk about those 3 things that are listed right here in my answer, or to the reader or whoever is looking at this. I want to make sure I include this information. So describing these patterns I see on the graph, well, what it relates to. Looks like this graph relates to the number of steps and the total height of them. So I would maybe want to mention something like that. I would maybe say for this first part, how the height of how the height increases as the number of steps increases. Where does it start? I'm looking at my first data point. It starts at the first step being 20 centimeters. How it changes is the third thing I want to describe. It looks like for every step, my height increases by 20 centimeters. And so maybe I'll just describe that in words to you right now. So again, for every step, the height is going to increase by 20 centimeters. So that is one task you guys are going to be expected to do at the end of this. Describe these 3 things as you look at a graph. Number B, make a table of values from the graph. So if I'm asked to do this, I'm going to start with a t. The number of steps. This first column relates to my x-axis, so I'm going to put number of steps here. And this second column always relates to the up and down. The y-axis is what it's normally called. I'm going to put height here in cms. And then I'm going to do this in a sequential way, in an orderly way, starting from the lowest number of steps moving to the highest. So my first point, and at this point I'm just describing these red dots and the coordinates of them. So if I have 1 step, my height is 20 centimeters. If I have 2, it's going to be 40, 3, 60, 4, 80. Might be asked to make a further prediction as well. If the pattern continues, what is the total height of step 10? Well, it looks like there's some type of relationship. I don't have a data point there. I don't have my number of steps going up to 10. But what I notice is that in every single case on this table of values, it looks like there's some type of multiplier between this number and this number. So to me, it looks like if I multiply 1 by 20, I get 20. 2 times 20 would give me 40. 3 times 20 would give me 60. So when I'm asked to, based on this pattern, if it continues, what's the total height of step 10? Well, I'm probably just going to multiply 10 by 20 to get 200. 10 steps times 20 centimeters for each step would give me 200 cms. That's how I thought of it. Okay, in some cases we're going to be asked, does it make sense to have data points between the ones that are shown? And so we need to ask ourselves, yeah, would it make sense to have data points between these blue ones on this graph? So we have this graph, it's showing the total cost for lunch when Will and his friends buy a large salad to share and several slices of pizza. So, couple things about this graph. We have number of slices purchased on our x-axis. We have the cost in number of slices purchased here. We have our cost in dollars right here. And so if Will and his friends, if they bought 0 pieces of pizza, they still got to pay $7.50. Because they also bought a salad too, right? It says in our question. I guess you guys can't see it up there, but they bought a salad. And so if they get 1 piece of pizza, it looks like that's about $2.50. If they have 2 pieces, looks like the price is increasing by $2.50 for every slice of pizza that they are ordering. Now, my question is, would it be possible to put a data point here or here? Or in other words, could there be like a real cost associated with this? And I'm going to say this is a case where data points don't exist. Sometimes they will, but in this case they don't. Because if you go to a pizza store and you just ask for half a slice of pizza, chances are they will not sell you just half a slice. Maybe you go in there and say, oh, my 2-year-old, he can only eat half a slice of pizza, I only want to buy half. Well, unfortunately, the pizzeria is probably just going to make you buy the whole thing and you're going to have to eat the other half. So this is an example where data points don't exist between the ones shown on this graph. So this is going to come up on your assignment. In some cases, it will not make sense to have data points in between the given ones. And in years past, in grade 8, we've actually phoned some pizza restaurants and asked if we could buy like half a pizza or like half a slice. And every time, the answer has been no. So I've tried it. And so you're just going to have to believe me on this one that it's not possible. At least not based on the restaurants that I've called anyway. So that's, I think that's pretty much it. There's going to be some review questions for you to do and an assignment which I will post today. Yeah. Take care. Hope everyone's doing well.